Let us solve the exercise number 4 in the part B of our programming lab. In this exercise, a scenario is given, and the scenario is as follows. The time taken by a large group of students to complete a piece of homework, 3 minutes, are normally distributed with the mean of 57 minutes and the standard deviation of 6.5 minutes. Find the probability that the time taken by a random student from the group to complete this work will be less than 60 minutes. They have also asked us to write the R script to find the probability that the time taken by a random student from the group to complete the work in less than 60 minutes, and the next one is between 50 and 80 minutes. So let us go ahead and let's calculate this one. So what is given, essentially what they want us to do is we have to find the probability that the time taken is less than 60 minutes, probability for 60 minutes, that is less than 60 minutes, when the mean is given, that is 57 minutes, and the standard deviation is given as 6.5. So when the mean is 57 and the standard deviation is 65, for the 60 value, that is x equal to 60, what is the probability? That is what they want us to calculate. Let us go to the R Studio, and I'm going to go to the file and I'm going to click on new and R script. Let me write the R script. So what is that I am supposed to do is I am supposed to use a function for the probability for normal distribution. So that is the P norm. Remember, there are a lot of options are available for that one. That is for this P norm. We have P norm, D norm, and so on and so forth. So I'm going to use the P norm. And what is the first thing? So first we are supposed to get the value for which we were supposed to calculate, that is less than 60 minutes. And what is the next one? Next one is mean and standard deviation is being asked. So if you look at the mean is the 57 minutes and the standard deviation is 6.5 minutes. So I'm going to just write that 57 minutes and the standard deviation is 6.5. Let me just not confuse the R. So I'm going to just say mean is 67 and the standard deviation ST equal to that, just so that I get the correct answer. So I'm going to select this one and I'm going to just run it. So I'm going to get the answer that the probability is 67%. So that is it, 7.77 and 67.77% is the probability. So this is the probability for the value less than 60. Now, if you are wondering what is this P norm and other things, there are related ones are there. So what you can do here is you can just say question mark and then type the P norm function. So just type P norm and press enter. You will be shown the options. Remember, that is what I told you. There is a related functions are there. You have D norm for density. P norm you know very well, distribution function, that is a probability distribution function. If you want quantile, you have Q, and if you want the random generation, you have R norm. So many functions are there, out of which we will be using this one with the only option, that is a Q, and Q is the quantities that you want to use it, mean and the standard deviation, lower tail, and we are not going to use it. By default, it is true. And log.p is false. If you again want to know what is this log.p is the logical true, probabilities p are given as logs. So that is it. You can use this one. The next one is what is given over here is we are supposed to get the value between 50 and 80. That is what is being given. So what is that we are supposed to do is first we are supposed to calculate the value for 80, that is a probability for 80, and subtract it the value. Again you calculate the probability for 50, subtract the 50 from the 80. This is what you are supposed to do it. So let me go ahead and let me do that thing. I'm not going to write it one more time. So I'm going to write this same function and I'm going to say probability for 80 the mean and standard deviation remains same. There is no change. And minus probability for 50. This is what is being asked. Probability for 50. So these two are being asked. So just select it and just run it, or you can run both of them. You really wish to do so. So it is 85.9%. So that is 0.859 is the value that is being used. So this is regarding the way in which R solves the problem. Now you are supposed to solve it manually. So how do you solve it manually? In your record book or in your book, you have to first write this one, that is the R script. What is the output? You write the output for both of them. And then the next thing that you are supposed to do is manual calculation. So let us first do the manual calculation and then see how we can solve it. So the first question is for probability that the time taken is less than 60 minutes. So x is 60 here, mean is 57 as given, standard deviation is 6.5. Let us calculate the z score for that. Z score is x, which is 65, minus the standard deviation, which is 57, divided by x minus the mean, which is 57, and divided by the standard deviation, which is given as sigma is for standard deviation, mu is for the mean. So you substitute the value 60 minus 57, that is your mean, divided by the standard deviation, that is 6.5. So 60 minus 57 is 3. 3 divided by 6.5. You are going to get the value as 4.4615. So use this 0.4615 in your Z table and get the value. So if you have the Z table, so this is the value. So Z distribution, that is standard normal distribution. If you have the one with the negative as well as the positive, then you can use straight away, you can get the value. So what is the meaning of that is the curve that you are going to draw will be of this, you know very well, normal distribution curve will be a bell-shaped curve. So it will be a bell-shaped curve here, and the 50% value will be there in the middle. So this will be the middle. So starting from minus infinity, generally, to be very precise, to plus infinity, these values will be there. But the curve, the entire curve, the area under the entire curve is 1. That means the probability is 1. The first half, this value, let me just show this value, that is first half, the probability is 0.5. So this this side is 0.5, the other side is also 0.5. Suppose if you are starting from the left side, if you calculate all the values from the left side, go up to here, then you can use this one. You can notice that area to the left of Z score. So that is what is being given. So what is the meaning of that is you have the bell curve here. So this is the normal distribution. Isn't that this is the normal distribution? If somebody asks what is the value here, Z value, if the Z value is given, you are going to get this table, the one table that is shown over here. It's going to give you the probability up to this left side probability. It's going to give you this left side probability. That is what is given over here. The area to the left of the Z score. So suppose if the Z score is something, you get some Z score value, some Z value here. So this table is going to give you all the values less than that, all the values from negative to up to this point. It's going to give you the all the values below before this curve. So all these values, it's going to give you the answer. So let's try to use this one. I will just show you this one, how this can be used, and the one that is given by the university. Let us see the difference. So this is the question here is the value which is less than 60 minutes. So what is the meaning of that is you are supposed to, if this is the curve, if this is the curve over here, So if this value is 60, just say this is 60, then all the values, all the probability which is less than 60. So this less than 60 value is being asked there. So let's go here and let's look at the Z values. This is zero point 0.4 and 6.15. So zero point 0.4, let me just search for zero point 0.4 here. So you have this zero point 0.4 here. So this is zero point 0.4. And so you just go to zero point 0.4 here, and 0.46 was there. You take this value. So that is 0.6772. This will be the value. So this is corresponding to 0.6, sorry, 0.46, 0.46. You will not take the other two values. You will only take this zero point 0.4 and 6. So zero point 0.4 and 6. If you take it 0.4 and 6, so this is 0.4 and 6, so you are going to get the value for the first question. That is, you are going to get the value as the area under the curve for this one, 0.67724. This will be the value. If you compare this with the one that is obtained by our R studio, so you notice the 0.677 something you are getting it, and what we are getting is also here for 6.677. So you are roughly getting that same value. So 3 digit, definitely 0.677 you are going to get it. Okay. Now this is if you are using the area to the left of it. But what is given in by the university is this, wherein you don't have the negative value, so you are not starting from the this side. The university, the curve, you are not starting from here, and you are not taking all these values. Negative side value, this other part of the values are not taken. So what is being taken is you are taking all the values from here. Remember, again, just recall, this curve is divided into half. The total area is 1. Okay. Left side of this, you see the separation here, left side, the middle value. So this middle value, left side of the middle value, you have the probability 0.5. Right side also you have the probability 0.5. Total value will be 1. Okay. Now what is asked in the examination? So this is 50%, that is 0.5. This is exactly 50%. What is asked is 60, so slightly more than this. 60 is asked here. So what is 60? 50%. Remember what is 50%? 0.5 first half. And whatever the values that you are going to get it here. So whatever the value you are going to get it here, that is going to make it as 0.5 is for the first 50%. So this 50%, 0.5, and whatever value you are going to get, that you have to add it to 0.5 to get the result. So let us try to get the result here. So what is the Z score that we have got? Let me just go here and get the Z score value. So the Z score is 0.4 and 6, zero point 0.4 and 6. So let's go ahead and let's do that thing. So I'm going to go to the zero point 0.4. Let me just go to the zero point 0.4. So 0.4 and 0.6. So let's look at that thing. 0.4 and point. So this is it. 0.46. 0.4 here is there, and 0.6 here the value is this one. So that is 0.1772. So this is the value. Just take this value and put it there. So you get the value as a 0.1772. Remember this part 0.1772. So this is the curve. Okay. This part is only from 50% to that 60%. Only this 10% value is this thing, that is 0.1772. But I have already told you, you have to add, because it is the time taken less than 60 means you have to add the remaining. So this is only 10% here. 50 to 60, only 10% is there. Remaining 50% value is 0.5. So you have to add that 0.5 So you have to add that zero point 0.5 to the whatever value you are getting, 0.772. So add that value, you are going to get it, the value as 0.6772, which is also same as what I have shown you here. So 0.677, and R will give you much accurate value, whereas when you do the calculation, you will get approximately, you are going to get that value. So in any case, what is the essence of this is 67.77% is the answer that you are going to get. Now let us look at the second question. What is the second question? Second question says in between 80, in between 50 and 80. How do you get in between 50 and 80? What is the solution? Remember, you have this curve here. You have this bell curve, let's say. So this bell curve is there. First get the value for 80. First get the value. So let's assume that this is 80. I'm just giving some value. This is 80. So let's assume that this is 80. You get all the area before 80. You get this 80. Yeah, before 80. Entire probability before 80. So you get this entire area before 80. We got this one. Now go for the 50. Next one is 50. So this is 50. Next, take the value for 50. So just assume that this is a 50. So this is 50, and this one was 80. This one was 80. Okay. Remember again, this is if you are taking the value. So this will be the starting from the beginning, less than 50. You take all the values less than 50. Okay. So this is for 50. What is left in between? So what is left here, this area, what is left here is the probability for 50 to 80. So 80 minus 50, if you do 80 minus 50, you are going to get the probability in this region. So this region is 80 minus 50. So you are going to get that value. And this is what you have done here. So here what you have taken is 80 minus 50. So 80 minus 50, you put the negative sign here, 80 minus 50, you're going to get the value as point, I'm not getting this, okay, you're going to get here, this is the value. So I'm going to use the distribution, the one that is not supplied by the university. I'm going to just show you here, and then we will go back and look into how the university given values, how do we calculate it. This is going to go with the negative also. Okay, so you can easily use this one. Remember, this is area, the probability area from the left hand side. So from the z-score, all the value in the left hand side is going to do it. So let's first calculate this, and then we will go ahead with the value. We will start with the first one for the probability 50. Remember, we have to go 80 minus 50. Let us calculate this part, 50 part, and then we will calculate z values for 80, and then we will subtract it. So let's calculate this one. So x is 50. Z score is x minus the get that x minus the mean divided by the standard deviation. The values mean and standard deviation is same. So 50 minus 57, which is mean, divided by standard deviation, which is 6.5. 50 minus 57 is minus 7 divided by 6.5. You are going to get the value as 1.0769. So you're going to get this one. Let us do it for 80 now. So the value of next value is 80, and 80 minus the mean divided by the standard deviation. Again, the mean remains same, 57, and standard deviation is 6.5. Substitute 57 and standard deviation. You get 80 minus 57, which is 23 divided by 6.5. You are going to get something as 3.5385. Now, if you look at this value here, this is minus 1.07. Remember, if you round this off, you can carry 1 here. Okay? If you round it off, you can make it as 1.08. This is 8. If you round it off, you can make this instead of 7, you can make it as 8. Okay, but I will take it as 7 itself. So when I take the 7, definitely approximation error will be more here because I'm losing too much of a thing there. Same thing is true for this one also. If you look at this one 3.5, if you look at this one 3.5, and you have a 3 here, after 3 you have 8 here, so you can carry 1 here and make it as 3.54. So just if you do that rounding of, you will reduce the errors to a great extent, but I will just use 3.53. Now let's use the one area to the left of the curve first to find out what is it. So this is minus 1.07. So you will not use this one, you will only use this 1 point, this part we will not use it. So we will only use 1.07. So let's go with 1.0 and 7, negative sign is there. So I'm going to go here with 1.0. Notice this 1.0, this is 1.0, and then 7. So 1.0 and 7. So next value is 7. So where is this 7? If you look at here, this is 7. This column is for 7. So you go down, down, down here. So this is the entire column is 7 column. So this is the 7 column. So you notice this whole thing is for 7 column 0.07. So go go down and then go for this column and this value. So this is going to be 0.1432231. This will be the value. So that is 0.14231 will be the value. I'm going to just copy this one. I'm going to just take it and just copy it into the notepad for my reference. So I will just use a 0 point. Again, 2 points are there. Let me just do this one. Okay. Now let us look at the second one. Let me go to the second value, which is here for 80. So this is for 50. So this is for 50. Let us go for the 80. 80 is 3.3. I will not take the other two values. So I will just ignore these two values. So I'm going to just 3.5 under 3. So let us look at the 3.5 now. This is positive 3.5. So you have this 3.5 here, 3.5 under, so 3.5 under 3. So 3.5 under 3. So this is 0, 1. This column is going to be the 0.03. So let's go down 3.5 for this 3.5. This will be the value. So for 3.5, this will be the corresponding value. So I'm going to take this one as 0.9997. So this is the value I'm going to take it. I'm going to just paste it here in the notepad. So this is 0.997. Okay. So I'm going to subtract this minus this. So this is what I was supposed to do it. So this is the curve. This is the bell curve. This is the bell curve. And the first thing that I have done is I've taken the value for 80. So the value for 80 is 3.7 something. So this is going to give me the entire, the area before this, the area before this is going to give me. Then what I did was I took 50 here. So this is 50. This probability is for 50. So this is for 50. Okay. Now this will also give me some values here. So this value here. What I want is this is 80. This is 50. Okay. What I want is 80 minus 50. So this is going to give me all the values which are in this region. So all the values within, under this curve in this region it's going to give me. So this is the value that I am interested in, 80 minus 50. So let us take this one. I'm going to just copy this one, Control C. I will take it to my Windows calculator and I'm going to just click here and Control V and press equal to. So I'm going to get 0.85784. So if you compare it, it will be very less than what you can expect here. So you notice that it is 85.7. You are getting 85.9 here. So why it is less? Remember, we have done approximation. What is the approximation we have done? When you took the values, we have not taken 8.34. You should have taken 8.34, because when you round off 8, you can get it round off to 2 decimal place. You can do it. Same thing here also. We have taken 1.0 and 7. Instead of 7, if you take 8, you will get roughly closer to that value. Now, this is if you have the area before the curve. But what is given by the university is not area before the curve. So they are missing this zero point 0.5 values. They are missing this zero point 0.5 value. So they are giving you only this value, and this value, two values. So what you are supposed to do is you add these two values. In this case, you have to add, that is 50% value you Z value and 80% value, you add them together. When you add, you are going to get the answer. So you just add them and you are going to get the area area between 50 and 80. So let us first calculate using this table. The table that is, if you notice, you don't have negative in this one. The one that I am using, the area to the left of it, you will also see the negative values here. So if you get a table with the negative value, just take their value directly. If you get the positive value, you need to do some compensation. If they ask for area before the Z value, you have to compensate with 0.5. Okay, but in this case, that doesn't make any difference whether when you take this one as 80 and when you take this as 50, okay, 50% and 80%, this value will be automatically, this will be deducted automatically. 80 and minus 50, this value gets deducted in both the cases. So let us go ahead and let's do the calculation. I'm going to go here to my calculation. So for my 50, it is, remember, ignore this one because you don't have the minus sign there. Just ignore that negative and then start with the, what is this, 1.07. You ignore again, ignore this 16.9. This is not going to take again. That will create an approximation error. That's okay. So I will take this as 1.07, 1.0 and under 7. Let's look at that one, not in this one, the one that is given. 1.0 is given here, 1.0 is given here. So 1.0 under 0.7. So this is under 0.7 is this 1. So let me just change the color. Okay, under 0 is this one. Okay, so this is the value 1.0 under 7. So this is the value that is being given over there. So what you have here is 0.3577. So let's take a note of that one. So I have already made a note of that. So for that is 0.3577. So this is the value that is being taken for this one, 0.3577. So this is the value. If you notice, for 1, so for 1 under 7, for 1 under 7, this will be the value. So that is done. So I got this value is done. Now let's look at the next one. I'm going to go here and I'm going to take this value. What is the 80? For 80, the Z score I got is 3.53, and this is not really required. Okay. So this is not really required. So I'm going to take 3.53. So let's go and let's search for 3.5. I'm going to just 3.5, and which is the area 3.5 under 8. 8 is here. Last but one is the 8. So let me just go to 3.5. So 3.5. This is the value 3.5. So if you notice, this is the 3.5. Last but one, so this is for 8. Last one is 0.9, so this is 8. 0.4998. So this value is 0.4998. Let's go here and let's look at that one here. So I made a note of that. For the next one is 0.4998. So if you notice here, 0.49, 3.5, 0.4998. So this is the value 0.4998. This is the value that I've taken. Here you have to just add them because you are using the other one. You just add them together. So 0.493 plus add it. So you're going to get the same value 8575, but the R will give you a slightly good value, that is 859. You are getting 85.9%. You are going to get here because of error of approximation. You will get 85.7. Reason you have not rounded it off. If you round it off, both of them, you will get approximately same value as the one that is given by R. So this is what you are supposed to do. That is 85.75%. So in between X is 50 and 80, you are going to get 85.75% as your answer. That is what you are supposed to do. It. Write all these things in your record book, and then you can use it. So during the examination, you have to solve it both using R, that is for which you get 6 marks, and for the solution that just now I shown you, you're going to get the next 6 marks. That's all. Thank you for your interest. We will meet again in the other exercise. Thank you.